The product of vectors chapter in the first exercise, third bit. In that the first problem is show that the points 5 comma minus 1 comma 1, 7 comma minus 4 comma 7, 1 comma minus 6 comma 10 and minus 1 minus 3 4 are the vertices of a rhombus by vectors. Here we are taking rhombus means this is the A, it is the B, it is the C, it is the D. A is A vector, B vector, C vector, D vector. These are the vectors of the line equations, or according to that line, the vectors are the vertices. Vertices are the vectors. Okay, now we can prove that it is the rhombus. What are the conditions for the rhombus? In the rhombus, the main relation is the diagonals are not equal and both are perpendicular one to another, and the all sides are equal. In the rhombus, all sides are equal. Forms a rhombus means the first point of the rhombus condition is all sides are equal. That is nothing but the length of the sides are equal. Second one is diagonals are non-equal. Diagonals are not equal. And the diagonals are bisect each other. Diagonals are bisects each other. When we can prove these relations, then we can say that these vertices are forms a rhombus. Okay, and those vertices are as vectors. It's not a point, that is a three-dimensional vector. That is nothing but 3x, y, z coordinates are there. Here first we can take the given points. Given points are, let it be, capital A is equal to 5 comma minus 1 comma 1, B equal to 7 minus 4 7, C equal to 1 minus 6 10, D equal to minus 1 minus 3 4. These are the vertices of the rhombus. Let it be OA, write in the vector form. So OA line is the A vector, that is equal to 5i minus j plus k. OB vector is equal to B vector, that is 7i minus 4j plus 7k. OC vector, it is equal to C vector, that is I minus 6j plus 10k. OD vector, that is equal to D vector, equal to minus I minus 3j plus 4k. Now we can find out the distances. AB distance. AB distance is nothing but under root of x2 minus x1 whole square. That is nothing but OB vector minus OA vector is equal to AB vector, and its magnitude is modulus of magnitude. That is the magnitude of OB minus OA. OB minus OA means 7 minus 5. 7 minus 5 I plus minus 4 minus into minus plus 1j plus, it is the vector. First we can take it as a vector, then we can find out the magnitude. Why? Because you are getting some confusion. That's why first we can find out the vector. AB vector means that is OB vector minus OA vector. It is equal to 7i minus 4j plus 7k minus 5i minus j plus k. Subtract from one to another. 7 minus 5 is 2i, minus 4 minus into minus plus 1, minus 3j, plus 7 minus 1, plus 6k. Modulus of AB vector is equal to under root of 2 square plus minus 3 whole square plus 6 square. It is equal to under root of 4 plus 9 plus 36. It's a 49. Root 49 is equal to 7. The length is 7. Similarly, we can find out the BC. BC line is equal to OC line minus OB vector. That is equal to OC is I minus 6j plus 10k minus OB is 7I minus 4j plus 7k. It is equal to 1 minus 7 is minus 6I minus 6 minus into minus plus 4 minus 2j plus 7 minus plus 10 minus 7 plus 3k. Find out the modulus of BC line, that is under root of minus 6 whole square plus of minus 2 whole square plus 3 square. That is under root of 6 6 are 36 plus 2 2 are 4 plus 3 3 are 9. Again we are getting the root 49. It is equal to 7. Next to find out the CD line. OD minus OC, it is equal to OD is minus I minus 3j plus 4k minus OC is I minus 6j plus 10k. It is equal to minus I minus 2I minus 3 plus 6 plus 3j plus 4 minus 10 minus 6k. Modulus of CD line is equal to magnitude under root of minus 2 whole square plus 3 square plus of minus 6 whole square. It is equal to under root of 2 2 is 4 plus 3 3 is 9 plus 6 6 is 36. Its root 49 is equal to 7. Next to find out DA. DA equal to OA minus OD. OA is 5I minus j plus k minus OD is minus I minus 3j plus 4k. It is equal to 5 minus into minus plus 1. 6I minus 1 plus 3 plus 2j plus 1 plus minus 4 minus 3k. Magnitude of dA, that is nothing but length, dA vector, that is length 6 square plus 2 square plus minus 3 whole square. That is equal to under root of 36, 2 2 is 4 plus 3 3 is 9 equal to root 49. It is equal to 7. Here, here all sides are equal. Here we are getting modulus of AB length, magnitude, and BC length, CD length, DA length is equal to 7. Next we can find out the diagonals. Diagonals means, what are the diagonals here? BD, AC, diagonals. Here we can take BD means OD minus OB, AC means OC minus OA. Here taking BD line equal to OD minus OB. It is equal to OD is minus I minus 3j plus 4k minus OB is 7I minus 4j plus 7k. It is equal to minus 1 minus 7 minus 8I minus 3 plus 4 plus j plus 4 minus 7 minus 3k. Modulus of BD vector is equal to under root of 8 8 is 64 plus 1 1 is 1 minus 3 whole square is plus 9. It is equal to root of 74. Next to find out the AC line. That is AC vector means OC vector minus OA vector. OC is I minus 6j plus 10k minus OA is 5I minus j plus k. Subtract from one to another. 1 minus 5 minus 4I minus 6 minus into minus plus 1 minus 5j plus 10 minus 1 plus 9k. Find out the modulus of AC, that is equal to under root of 4 minus 4 whole square plus of minus 5 whole square plus 9 square. It is equal to under root of 4 4s are 16, 5 5s are 25, 9 9s are 81. It is equal to under root of 97, 6, 11, 12, 1, 10, 12, 122. Here clearly modulus of BD is not equal to modulus of AC. So diagonals are not equal. The second one is over. Diagonals are not equal. First relation is all sides are equal. Next, third one is we can prove that the diagonals are bisects. That is nothing but dot product. BD vector dot AC vector, is it equal to 0? Then bisects means perpendicular to each other. Minus 8I plus j minus 3k dot minus 4I minus 5j plus 9k. It is equal to minus into minus plus 8 4s are 32, plus into minus minus 5, minus into plus minus 9 3s are 27, minus 27 minus 5 it's 32, plus 32 minus 32 it is equal to 0. So here BD line is perpendicular to AC line. Therefore diagonals are bisects. Therefore from the above conditions, A, B, C, D vertices are forms a rhombus. It is the solution. The second question, let A vector equal to 4I plus 5j minus k, B vector equal to I minus 4j plus 5k, and C equal to 3I plus j minus k. Find the vector which is perpendicular to both A and B and whose magnitude is 21 times the magnitude of C. First, we can find out the vector equation which is perpendicular to both A and B. What is the formula? The vector equation is perpendicular to both A and B is equal to A vector cross B vector by modulus of A vector cross B vector. This is the formula. And that vector which is perpendicular to A and B and whose magnitude and this magnitude is 21 times the magnitude of C. That is nothing but the vector which is perpendicular to both A vector and B vector whose magnitude is 21 times the magnitude of C. that is equal to 21 into magnitude of C into magnitude of A vector cross B vector by modulus of A vector cross B vector. Why? Because it is a vector, we can find out the modulus. So here this is equal to, first we can find out the magnitude is nothing but we can take the plus or minus. When they are asking about the magnitude means plus or minus. Plus or minus 21 into under root of, first we can take the vectors. First we can take the given vectors. What is A vector, what is B vector, what is C vector. Given that A vector equal to 4i plus 5j minus k, B vector equal to I minus 4j plus 5k, C vector equal to 3i plus j minus k. Here find out the modulus of C vector. Mod C vector is equal to under root of 3 square plus 1 square plus minus 1 whole square. 3 3s are 9 plus 1 plus 1. It's root 11. And find out the A vector cross B vector, that is equal to determinant I, j, k. A is 4, 5 minus 1. B is 1 minus 4, 5. It is equal to I into 5 5s are 25. Minus into minus plus again minus 4. Minus j into 5 4s are 20. Minus into minus plus 1 plus k into 4 into minus 4 minus 16 minus 5. It is equal to 21i minus 21j minus 21k. If 21 is taking common, I minus j minus k. What they are asking? Okay, they are asking the vector means here no determinant. It's already in the denominator, magnitude is there. So it's no determinant. Here we can apply that modulus of A vector cross B vector is equal to 21 whole square into 1 square plus minus 1 whole square plus minus 1 whole square is equal to 21 root of 1 plus 1 plus 1. It is equal to 21 root 3. Here the vector which is perpendicular to A and B and 21 times of modulus of C is equal to plus or minus 21 into mod C into A vector cross B vector by modulus of A vector cross B vector. It is equal to 21 into modulus of C is root 11. A vector cross B vector is 21 into I minus j minus k by 21 root 3. 21 get cancelled. It is equal to 21 into root 11 multiply and divide with root 3. Already here I minus j minus k by root 3. Root 3 into root 3, 3. 3 ones are 3 sevens are. It is equal to 7 plus or minus 7 into root 11 into 3, 33 into I minus j minus k. It is the solution. Here, which is the magnitude means we can taking the first vector equation, that is the 21 times of magnitude of the C vector means we can remember this formula. Okay.
Hello.
Problem. G is the centroid of triangle ABC and ABC are the lengths of the sides BC, CA and AB respectively. Prove that A square plus B square plus C square equal to 3 into OA square plus OB square plus OC square. First, we can take the triangle. The triangle is ABC triangle. Here they have given small a for BC, that is opposite, small a for BC, small b for AC, small c for AB. Those are the lengths. ABC are the lengths of the sides. Those are constants only, not vectors. Why? Because its magnitude means length of the sides only. Prove that here O is any point and G is the centroid. This is G is the centroid. G is the centroid means from the centroid we can from O point OA, OB and OC is equal to G. We know that the centroid formula is in the 10th standard we studied that one. A plus B plus C is by 3 equal to centroid is the G. So we can write it as G is equal to, suppose O from the O point means OG, 3 into OG is equal to OA plus OB plus OC. That is the relation of the centroid relation. First of all, we can take the relation and what they have given. Here, given that G is the centroid of triangle ABC and small a, small b, small c are the lengths of the sides BC, CA and AB. That is nothing but BC length is equal to modulus is A, CA length is small b and AB length is small c. The here centroid means we have this relation. Here what we can prove that? To prove that small a square plus b square plus c square is equal to 3 into OA square plus OB square OC square minus 9 into OG square. Okay. Here a square is nothing but what is that? BC. A square equal to BC square. BC square is nothing but OC minus OB whole square. Here A minus B whole square form OC square plus OB square minus 2 into OC into OB. That is nothing but here OC square plus OB square is, we don't know the value. Why? Because it's we have only lengths. Next, similarly, we can find out the B square is equal to CA whole square, that is OA minus OC whole square. It is equal to OA square plus OC square minus 2 into OA into OC. C square is equal to AB whole square, that is equal to OB minus OA whole square equal to OB whole square plus OA whole square minus 2 into OB dot OA. Adding of these all three relations A square plus B square plus C square is equal to, here 2 into OA square, 2 into OB square, 2 OC square. Here all are different. So we can write it as 2 into OA square plus OB square plus OC square minus 2 into OC into OB plus OA into OC plus OB into OA. This is the let it be equation 1. Okay. Next we can consider the centroid. What is that? 3 into OG is equal to OA plus OB plus OC. Here we have the square terms, so we can take the relation of the centroid they have given. That centroid related equation can be squaring on both sides. Let it be equation 2. Why? Because G is the centroid from the origin of any point, from any point of G is centroid from O. So here squaring equation 2 is squaring on both sides. When it is squaring on both sides, it can be as in A plus B plus C whole square. Here 3 3s are 9 into OG whole square is equal to OA plus OB plus OC whole square. That is equal to OA square plus OB square plus OC square plus 2 into OA into OB plus OB into OC plus OC into OA. It is the formula. Here, this is replacing of this one. So, it is the OA square. Equation 3 can be substituted in equation 2. But here, what we have the relation, what we can prove that A square plus B square plus C square is equal to 3 into OA square plus OB square plus OC square minus 9 into OG square. So, for that, here in the left side, A square plus B square plus C square is there. Here 2 is already there. From the second, third equation, or from this 2 into OA into OB plus OB into OC plus OC into OA is equal to 9 into OG square minus of OA square plus OB square plus OC square. Let it be equation 3. Equation 3 substitute in equation 1. Here in the place of 2 into OA into OB plus OB into OC plus OC into OA, in this place we can substitute this one. So A square plus B square plus C square is equal to 2 into OA square plus OB square plus OC square minus 9 into OG square minus OA square plus OB square plus OC square. Simplify. It is equal to 2 into OA square plus OB square plus OC square minus 9 into OG square, minus into minus plus OA square plus OB square plus OC square. So 2 plus 1 is 3. It is equal to 3 into OA square plus OB square plus OC square minus 9 into OG square is equal to A square plus B square plus C square. So it is proved. It is a solution.